Consider the following example. A cannon pointed straight upwards shoots out a projectile. As we would expect, the projectile leaves the cannon and moves upwards. We can see it slowing down until such point that it stops moving. At this point, it has reached its maximum height. It then begins to fall down again. So what's happening here? As the projectile leaves the cannon muzzle, the cannon no longer exerts any force on it, so the only force acting on the projectile is the force due to gravity. Because gravity wants to pull the projectile downwards, it acts to slow the projectile down. Remember, the acceleration causes a change in velocity. Since the direction of gravity is downwards, but the projectile had an initial upward motion, then gravity is acting in the opposite direction as the direction of motion. Therefore, there is a negative acceleration or deceleration. Let's look at the velocity and acceleration vectors in the first half of the motion. The initial velocity vector points up and the acceleration vector points down. As the projectile continues to move upwards, the velocity vector gradually gets smaller and smaller until it becomes zero, at which point it stops moving. All the while, the acceleration vector remains constant and continues to point downwards. After reaching its maximum height, the projectile will then start to fall and increase in speed as gravity continues to pull on it. Note that the total distance traveled by the cannonball is shown by the blue line that traces the path of the cannonball. However, the total displacement is the difference between the start position and the end position and is shown by the orange arrow. Remember that distance is a scalar and represents a magnitude only, while displacement is a vector and has both magnitude as well as direction. In this case, the cannonball lands on the ground just below where it started, so the displacement vector points downwards. Consider a cannon perched on a platform 5 meters above the ground. A cannonball is shot out of the cannon with the initial velocity of 20 meters per second directly upwards. It rises to its maximum height, then falls down and hits the ground that is 5 meters below the cannon. What is the total displacement of the cannonball? How long does it take for the cannonball to reach its maximum height? What is the maximum height that the cannonball reaches relative to the ground? What is the total time that the cannonball was in motion?